Welcome to our final review for algebra. This is going to be part 1 of standard 2. In this part we're going to talk about writing and graphing inequalities and also solving inequalities and that are a single variable inequality. We're also going to define, graph, and solve a system of inequalities in part 2, which will deal with systems of equations. Systems of inequalities. Anyway, let's look a little bit. This is just a review. You might find some videos online that cover some of this material, but inequalities describe a relationship that can have many answers. For example, if I come up to you and I say that John has more than $5, he could have $6 or $7 or $8, but not $4. So we can write a relationship that describes all those numbers rather than having to write them all out. And that is called an inequality. I'm going to write one. Most of you have seen these. So I'm going to say the amount of money, which I'm going to use the letter M, has to be greater than $5. Okay? This is saying that it can be 6 or 7 or 8. Let's plug the number 4 in here for money and let's see what we get. 4 is greater than 5. So we see that's not true, so we have written our inequality correctly. Now, there's some symbols we use in inequalities. We usually read them left to right, just like we do in English. So if I have this symbol, I'm going to read it as less than. If I have this one, I'm going to read it as greater than. Remember that the open side always has the larger number, and the smaller side always has the small number. So small number, large number. Okay? Now, sometimes the inequality also contains an equal. So if it's got a line underneath, it means less than or equal to or greater than or equal to. Best way I have heard so far to remember this, besides the fish eating the larger numbers, remember also that if you take the less than symbol, you can kind of make it look like, if you were to bend it a little bit, you could make it look a little bit like the letter L, if you're reading from right to left. Okay, so every once in a while we'll run into a problem where somebody wants to say something doesn't equal something, and they'll use an equal sign with a slash through it, which means not equal. Another situation that comes up sometimes is we'll have a number, an inequality symbol, then usually X, another inequality symbol, and a number. This usually tells you that it is between, the value of X is between those two values. And I believe there's an example here that we will use that in. Okay. Now, when we're graphing an inequality on the number line, the first thing we're going to find is the transition or break point. Remember, this is kind of a key. If it doesn't have an or equal to on it, like less than, greater than, it's going to be open because that point is not going to be part of the answer. If it has a line under it, or equal to, like less than or equal to, greater than or equal to, it will have a filled in circle. Then you're going to have an arrow going off one of the directions to show which side has the correct or possibly true answers. I guess possibly is not right, but that's where your answers are going to be marked, how you're going to show it. Okay, how to graph a single variable inequality on a number line. Just put this here so if you wanted to print it out you could, but basically we solve for the variable. Remember that if you multiply or divide by a negative number, it'll flip or reverse the direction of the sign. Graph the transition point, open and closed, we just talked about that. And then test one of the sides to see if it's true. Okay, so here's some extra examples that aren't in your review guide. I thought I would do them because the review guide has some special cases, but I wanted to just do some kind of general ones. Okay, on this one, I'm going to solve it just like I would if it were 3x plus 2 equals 4. In other words, to get the 2 on this side, I'm going to subtract 2 from both sides. It gives me 3x is greater than 2. Then I'm going to divide both sides by the number on the variable I want to get by itself, 3. And I'll get x is greater than 2/3. Notice the sign stayed in the same direction because even though these are negative, I didn't multiply or divide. I added and subtracted there. On the number line, we can graph things that aren't exactly on the integers. So this one is 2/3. I know 2/3 is about right here. If I wanted to be really exact, I might put 2/3 under it. It doesn't have equal, so it's going to be an open circle. Now, I'm going to plug these two numbers on either side in just to see how they work. 0 is greater than 2/3. I know that that is false. 1 is greater than 2/3. I know that's true. I know that 2 is greater than 2/3 and 3 is greater than 2/3. So that means that the arrow I draw is going to go this way to signal to me that all the numbers larger than 2/3 are going to make this work. Okay, we're going to do the same thing on this one. Just a little bit different example. I know the numbers look the same, except notice that I've got a negative on my variable, and let's see what that does. Negative -2 on both sides. I get negative 3x is greater than 2. Now I divide both sides by the number on my variable. And I divided by a negative number. And since I divided by a negative number, I'm going to change the direction of my sign. It's going to change the way I do my answer. I now know that x is less than negative 2/3. Draw my number line. Negative 2/3 is about right here. It's open because there's no line underneath it. And let's try some numbers. Negative 1 is less than negative 2/3. That is true. Remember, as you go this way, the numbers are actually smaller. 0 is less than negative 2/3. That's false. So false, true, that's true. So my line is going to go that way. Okay, now here's some of the ones from your worksheet. I'm going to zoom in a little bit on this one for a second. Here they want us to write it. And if we're going to write it, we need to have a good, clear picture of it. And we need to just basically do some of the ideas in reverse. I know that my break point is at negative 3, and I've got another break point at 4. So this is kind of one of those between situations. I look at the circle. It's an open circle. And it's smaller than the numbers that are going to work. So I'm going to put less than. Okay, I'm going to put my x in the middle. 4 is on the larger end, but x is going to be less than 4. So I'm going to put less than, and it also has a filled in circle, so I'm going to put or equal to. Sometimes you will see these written as two different inequalities, like negative 3 is less than x, and x is less than 4. Okay, now let's look at the next one here. It's not a between because the arrow keeps going. Break point is at 3. Okay, so x is something. Are the x's larger than 3 or less than 3? They are less than 3. So, and that'll do that one. Two little extra problems here. X is greater than 4. Show you how to graph it. My break point is going to be at 4, so I just put an open circle at 4 because it doesn't have the or equal. And the x's are greater. Greater goes this way, but I can also test a point, like I can test 5. Is 5 greater than 4? It is. Is 3 greater than 4? It isn't. So this point would have been false. That one would have been true. Okay, next one. Break point is going to be at 2. There's going to be a circle there. And it's going to be filled in because this is or equal to. I'm going to show you something that works here. 1 is less than or equal to 2. That's true. 2 is less than or equal to 2. That's true. And 3 is less than or equal to 2. That's false. So I can see that the direction is going this way. So I'm going to draw my arrow. I'm going to go back to this one and just test this point right in the middle. 4 is greater than 4. That's false. That's why it's open, and that's why it's filled in. Okay, that is going to be all.